Algebra 3, Chapter 2, Section 6, Composite Functions. Okay, so we're going to talk about combining functions, and you can add them, subtract them, multiply them, and divide them. The resulting equation that you get will also be a function. Any restriction in the domains of the original functions will also be restrictions in the resulting functions. So if you had something that the domain could not be in the original one or both of the original functions, even if that seems to change after you've done addition, subtraction, whatever to it, you still have to carry that through to the end. Remember that dividing two functions automatically will restrict the domain because we cannot have a zero denominator. Now, composition's a little different. The notation for a composition looks like this. You can have it with the parentheses or with the little circle. It's not fog, it's f of g. These are read f of g of x. Now, a simple way to think about it is that you're going to start with the inside and work your way out. For the above notation, I would take the value of x, I would put it into the function g first, then I would take the result of that and put it into f, and that result will be my final answer. If you're not given a value for x, then you will take the entire function g and put it in the place of the x in function f. So let's say f of x is x squared and g of x is x plus 2. We're going to find f of g of 3. Okay, I'm going to talk you through this. I like to rewrite it like this because it reminds me to start in the middle and work my way out. So I'm going to do g of 3. Well, g is x plus 2. So putting in a 3, I get 3 plus 2, which is 5, which means I need to take f of 5. Well, what are we doing with f? We're taking x and we're squaring it. So 5 squared is 25. Now you try g of f of 3. Pause the recording and try it, and resume to check your answer. Okay, again, you're going to start with f, and you're going to do f to the number 3, which means we're going to square it. So 3 squared is 9, and then we're going to take that and put it into g, which means we're going to take it and add 2 to it, which gives us 11. Okay, try this one. This is a little tricky. Remember, you're not going to have a value here. You're just going to replace, put whatever in the place of x. Pause the recording, give it a try, and resume to see how you did. Okay, so f of g of x. Well, g of x is x plus 2. So that means we're going to take x plus 2 and put it in the place of x, which means we're going to square it in f. So we get x plus 2 quantity squared. And you can leave it like that. Actually, I prefer it that way because I can see that you know what you were doing. Now try it the other way around. Pause the recording, give it a try, and resume to check your answer. Okay, so this time we're going to take x squared and put it in place of x in g. So we have x squared plus 2, and that's it. That's all you can do with it. Okay, the domain of the composite f of g of x is the domain of g of x that's permissible in the composite. In other words, you start with the domain of g, and then when you compose them, there may be additional numbers that you have to toss out of the domain. For example, we got f of x is 1 over x minus 1. Now immediately I know that f of x, the domain, x cannot be 1 because that would give me a zero denominator. So that's going to be a problem for f of x. For g of x, I need 3 minus x to be greater than or equal to 0. So solving that, I get that x has to be less than or equal to 3. So when I compose them, when I do f of g of x, I get f of square root of 3 minus x. So it's going to be 1 over the square root of 3 minus x minus 1. Now up front, like we said before, we know that the domain of g of x is less than or equal to 3. But we can't have our new denominator that we just made equal 0. So in addition to that, we need to say that the square root of 3 minus x minus 1 cannot be 0, which means the square root of 3 minus x cannot be 1, or 3 minus x cannot be 1, square both sides, so x cannot be 2. So my final domain is that x is less than or equal to 3, and x is not equal to 2. composing is actually, I think, a little bit easier. Probably part of the reason is that there's usually more than one right answer, and that helps. The key is to find the inner function. So let's say h of x is 1 over x minus 2 squared. Well, there's a couple different ways we can do this. We can say that our inner function is 1 over, or is x minus 2, and our outer function is 1 over x squared. So when we stick x minus 2 in place of x, we get 1 over x minus 2 squared. Another way of doing it is saying that our outer function is 1 over x, and our inner function is x minus 2 squared. So when we put x minus 2 squared in place of x, again, we end up with 1 over x minus 2 squared. There are probably some other ways that you could do this. These would be probably the two easiest. All right, so let's try these examples. You're going to find f plus f of g, f minus x, f times g, f over g, and you're going to give the domain of f over g. And you got two different problems here. Pause the recording, give them a try, and resume to check your answer. Okay, so here's all of those. You can look over it, make sure you've got it. I would caution you on part B. Make sure that you carry that minus through to both parts. And on part C, make sure you use FOIL. And the second one, a little bit tougher because we've got fractions involved and you have to get common denominators and things like that. So check your answers. And notice on D, the domain is all real numbers except x equals 0, which may sound a little strange. However, in the original functions, x was not allowed to be 0. And even though when we divided them, that fraction canceled out, because the original functions could not have x equal 0, in the end, we still have to respect that, and we still have to carry that through. Now try these. You're going to evaluate the indicative function for f of x equals x squared plus 1 and g of x equals x minus 4. Now let me remind you that f, g next to each other means times. And then if it was in with the parentheses or the little circle, it would mean composition. So we're multiplying and dividing, and we're not doing the composition just yet. Pause the recording, give these a try, and resume to check your answer. Okay, so f times g of 6 is f6 times g of 6. So just put in 6 for both of those, and we get 74. The second one, f of negative 1 over g of negative 1 minus g of 3. F of negative 1 over g of negative 1 gives us negative 2/5, and g of 3 gives us negative 1, so negative 2/5 plus 1, and we get 3/5. Now you're going to compose. You're going to do f of g, g of f, and weirdly enough, g of g. Now don't let that freak you out. You just take it, put it into g, and put it into g again. Pause the recording, give this a try, and resume to check your answer. So f of g of x is f of x minus 1. So that gives us x minus 1 squared. G of f of x is g of x squared. So that gives us x squared minus 1. G of x, that's g of x minus 1. So just put x minus 1 in place of x. Gives you x minus 1, which is x minus 2. Okay, let's try some more compositions. You're going to find f of g and g of f and the domain. Pause the recording, give it a try, and resume to check your answer. Okay, we know the domain. We're going to find the domain for the two functions first. For f of x, it's got to be x is greater than or equal to negative 4. And for g, it's all real numbers. So when we do f of g, all real numbers is our domain to start with, because you always start with the one on the inside. And then you see what you have after you compose it. When we compose it, we get the square root of x squared plus 4, and the domain of that is also all real numbers. And then g of f, we're starting with a restricted domain. X has to be greater than or equal to negative 4. Even though we're squaring that and we end up with x plus 4, we still have to say x is greater than or equal to negative 4 because that inner function had that restriction. For this one, f of x, the domain is all real numbers except 0, and g of x, the domain is all real numbers. And you can see when we compose f of g, we get f of x plus 3, which is 1 over x plus 3. Now, g of x had a domain of all real numbers. However, our composed function has an x in the denominator, so we cannot have x equal -3. For part B, when we reverse that, f of x had the restriction that x could not be 0. And when we compose them, we get 1 over x plus 3, and it's still obvious that x cannot be 0 for that one. Use the graphs of f and g to evaluate the functions. Now, let me give you a hint. When you do f of g of 2, what you're going to do is you're going to go to g, because that's the inner one. You're going to go to where x equals 2 and find the matching y value on the red line. Once you find that y value, you're going to go to the graph of f. You're going to take the y value you found in g, you're going to use that as your x value in f, and find the new y value. Pause the recording, give this a try, and resume to check your answer. Okay, so g of 2 is 2. When x is 2, y is 2 in g. So then we carry that over and we find f of 2, and f of 2 is 0. For part B, we do f of 2 first, which is 0. So we have to do g of 0, and that gives us 4. Now we're going to decompose. You're going to find two functions that when you compose them, give you the function you're seeing. There is more than one correct answer, so just because you don't get what I have here doesn't necessarily mean it's wrong. If you're not sure, then you should ask. All right, pause the recording, give this a try, and resume to check your answer. For our first one, probably the easiest thing to do is to let our outer function be just x squared, and our inner function be, that should actually be 2x squared plus 1. And so when we compose them, you put 2x squared plus 1 and put that in parentheses and square it, gives you the final result. For this one, again, this is one possibility. You can let your outer function be x plus 3 over 4 plus x, because you'll notice that the top and bottom both have a negative x squared. So let your inner function be the negative x squared, and then when you stick that in place of the x's, you end up with what you started with.